Now, so what does theorem 1 says? Theorem 1 says that adjoint of A into A is equals to what? A into adjoint of A, which is equals to determinant of A into identity, right? And when we come to theorem 2, theorem 2 states that if A and B are matrices of the same order, then if A and B are non-singular, then so is AB. And why does this happen? This happens because of what theorem 3 says. Theorem 3 says is that determinant of A into determinant of B is equals to determinant of AB. So if A is non-singular, so that means determinant of A is not equals to 0. And if B is non-singular, that means determinant of B is not equals to 0. And hence determinant of AB is not equals to 0. This implies that AB is non-singular. So when we are talking about singular matrices and non-singular matrices, the definition says that A, B and n cross n matrix, then A is said to be singular if determinant of A is equals to 0, and A is said to be non-singular if determinant of A is not 0. So that is what theorem 2 says, that if A is not singular and B is not singular, that means determinant of A is non-zero and determinant of B is non-zero. Therefore, determinant of A into determinant of B is non-zero, and hence determinant of AB is non-zero, which results that AB is also not singular. Next, what we were talking about was theorem 4, which says that A be a square matrix, A is invertible if and only if A is non-singular. So when we were talking about this, what does this mean? So from here, right? So when I'm talking about that A is invertible, what does that mean? A will be invertible if and only if you find a matrix B such that A into B is equals to identity. Yes. So that means that suppose A is non-singular. If A is non-singular, then by theorem 1, determinant of A will be non-zero. This is a number. So can we divide the entire equation by determinant of A? Yes. So if we divide the entire, so what we are given? We are given that A into adjoint of A is equals to what? Determinant of A into identity. Dividing by determinant of A on both sides, what do we get? A, right, into mod A, determinant of A into adjoint of A would be what? Equals to identity. Yes. That means what? That we have found a B which is equals to what? Adjoint of A divided by determinant of A such that AB is equals to identity. That means B, we have found A inverse. Yes. And what does A inverse look like? Adjoint of A divided by determinant of A. And vice versa, if we have that A is invertible, that means there exists a B such that A into B is equals to identity. Yes. So if we are given, on the other hand, if I am given that A is what? A is invertible. So if A is invertible, this implies what? That there exists a B such that AB is equals to identity, which is equals to BA. Yes. So if B looks like what? B11, B12 up till Bn, Bn1, Bn2 up till Bnn. Yes. Then can I form a B dash? Why? Because if A is non-singular, right? If A is we have to show that A is non-singular. So now what do we have is that we can say AB mod, that will be equals to what? Determinant of I, determinant of, we will talk about determinant of AB, that is equals to determinant of I, which is equals to determinant of B into A. Yes. So this implies what? The determinant of A into determinant of B is equals to identity, which is equals to determinant of B into determinant of A. Yes. And this implies what? That determinant of A into determinant of B is equals to 1, which is equals to determinant of B into determinant of A. And this implies what? The determinant of A cannot be equals to 0. Because if it was 0, then 0 into any number is 0. But this is coming out to be what? 1. That means determinant of A can't be 0. That means A is non-singular. So if A is invertible, this will imply that A is non-singular. And if A is non-singular, this will imply that A is invertible. Make sense? And what will A inverse of A look like? From here what we say is that inverse of A is nothing but what? A inverse is equals to what? Adjoint of A divided by determinant of A. So this is the new way that you calculate inverse of A without using elementary row operations or elementary column operations. This is how you calculate inverse of a matrix. Yes. So should we do it by an example? So we'll be doing example number 24, and what we'll do is we'll try to calculate the inverse of this A. Now, अभी हम लोग ने पढ़ा that A is invertible if and only if A is non singular. तो सबसे पहले हम लोग क्या करेंगे चेक करने के लिए that A invertible है कि नहीं है. We'll check the determinant of A is 0 or not. So सबसे पहले determinant of A की बात करते हैं. So कहाँ से कैलकुलेट करें determinant of A? First row से. So it will be 1 into 4 4s are 16 minus 9 minus 3 into 4 1s are 4 minus 3. Yes. Plus 3 into 3 1s are 3 minus 4. Yes or no? Yes. That would be equals to 16 minus 9 is 7 minus 3 into 1 is minus 3 plus 3 into minus 1 is minus 3, which is 1. So this is not equals to 0 and hence A is invertible. Yes. Now what would A inverse look like? A inverse from our previous proof only would look like what? Adjoint of A divided by determinant of A. Yes. Determinant of A is 1. So that means here in this case A inverse would be exactly what? Adjoint of A. So what we need to calculate here is adjoint of A. Now we are going to calculate adjoint of A. तो सबसे पहले हम लोग क्या शुरू करेंगे cofactors से. So A11, what would A11 look like? Minus 1 to the power 1 plus 1 into this gone and this gone. Yes. So what would 4 into 4 minus 3 3s are 9, that is 16 minus 9, that is 7. Yes. Then what would A12 look like? Minus 1 to the power 3 into this gone and this gone. You have 4 minus 3, that is 1. A13 would look like minus 1 to the power 4 into this gone and this gone. 3 minus 4, which is minus 1. Then A21 would look like minus 1 to the power 3 into what? Second row gone and first column gone. So this gone and this gone. 4 into 3, that is 12 minus 9. 12 minus 9 is 12 minus 9 is 3. And then what is A22? That is what? Minus 1 to the power 4 into 4 minus 3, which is 1. And then what is A23? Minus 1 to the power 5 into 3 minus 3, that is 0. Yes. A31 minus 1 to the power 4 into 3 3s are 9 minus 12, which is minus 3. A32 is minus 1 to the power 5 into 3 minus 3, that is 0. And last but not the least was A33. 4 minus 1, which is minus 1 to the power 6 into 1. Yes. So what is the resultant matrix? What is the your adjoint of A look like? Rows will become column. Yes. So this is what? 7, then minus 1, and then minus 1. Yes. And then this is the second row that we have. This will become the second column. So this is what? Minus 3, 1 and 0. This is the last row. This will become the last column. So this will look like what? Minus 3, 0 and 1. So this is adjoint of A, and that is exactly what is inverse of A. So what is inverse of A? 7 minus 3 minus 3 minus 1 1 0 minus 1 0 and 1. Isn't it faster?
Yes, definitely.
This is definitely faster than using row operations, right? So while I am talking about a 2 cross 2 matrix, let me give you a short trick. So when we are talking about a 2 cross 2 matrix, so what is a 2 cross 2 matrix? What does it look like? A, B, C, D. Yes, it has 4 elements. Yes or no?
Yes.
And by the definition, inverse of A is what? Adjoint of A divided by determinant of A.
Yes.
In this case scenario, what is determinant of A? AD into minus BC? Yes? AD minus BC? Yes or no? And when we talk about the cofactors, what will A11 look like? A11 would look like minus 1 ka square into what? D? Yes? What will A12 look like? A12 would look like minus 1 whole cube into what? C? Yes or no?
Yes.
What would A21 look like? Minus 1 cube into what? B? And what would A22 look like? Minus 1 to the power 4 into what? A? Yes or no? So the matrix Aij would look like what? This is what? D. This is minus C. This is minus B and this is A. So Aij would look like D minus C minus B and A. But by the definition, A inverse would look like what? A inverse would look like 1 upon determinant of A, which is AD minus BC, yes, into what?
D minus C minus
D minus B minus C and A. Because adjoint of A is what? Transpose of this matrix. Yes, ट्रांसपोज करते हैं ना इस मैट्रिक्स का, तो ट्रांसपोज करोगे तो क्या आ जाएगा? D minus C minus B A. So if we don't look at all of this, any 2 cross 2 matrix, हम determinant निकालेंगे, and then what? A and D would be interchanged, and B would become minus B, C would become minus C. And that is how we'll calculate a determinant of a 2 cross 2 matrix. So let me give you a 2 cross 2 matrix real quick. Take your minute. If I am given a matrix, say A, which looks like what? 2, minus 3, minus 1 and 2. Alright? So what would this matrix look like? This is 2, minus 3, 2 and minus 1. Determinant फटाक से calculate करो, इसका कितना आएगा? 4 plus, नहीं 4 minus 3.
determinant calculate करना.
हाँ, A का determinant कितना आएगा? 4 minus 3. Minus into minus into minus. 4 minus 3, that is 1. 2 into 2 minus minus 1 into minus 3. Minus 1 into minus 3 is plus 3. So 4 minus 3 is 1. What will be this be? Determinant of A would be 2 into 2 minus minus 1 into minus 3. 4 minus 3, which is 1. Right? So now determinant कितना है? Determinant is 1. So we have calculated this. This is determinant. We have done with this. Now we have to take A inverse. What will A inverse look like? A and D gets interchanged. So they are both 2, so 2 remains 2. And minus 3 becomes 3 and minus 1 becomes 1. This is exactly what A inverse is. So what you do is you interchange A and D and you just change the signs of B and C.
It means that whatever we will get, uska transpose.
Not transpose. If you do transpose, it will say A, B and D, C. Sorry, C, D. A, B, C, D. This is not this. You just interchange A and D and B becomes minus B, C becomes minus C, and then this resultant matrix is multiplied by the determinant of A. This comes from the basic definition. But in 2 cross 2 matrix, you can write it directly because it will always look like this. Alright? So today we'll end here and tomorrow we'll do applications of determinant matrices where we will learn how to solve linear equations with which we started. Remember, that is how we started. Determinants पढ़ना ही हमने शुरू कैसे किया था? Linear equation लेके. तो हमने कहा था अगर हमें inverse मिल जाएगा, so we'll do is A inverse x and we'll get the resultant xyz, जिसमें हमने सबसे पहला question किया था when we were doing matrices, right? So we'll solve linear equations. We'll see how we can solve linear equations in 3 variables because now we are studying 3 cross 3 matrices. So अब हमें 3 cross 3 matrix का inverse निकालना भी आता है. We'll study that and then we'll move forward.